Chapter 3, Lesson 1, this is Day 3, third option for solving systems of linear equations, and this time we're going to solve by elimination. So elimination is just like it sounds. We're eliminating a variable, okay? So you can see the steps here. You can read through them if you want. We're just going to follow those steps to solve these algebraically. So we have a system, and this is really what we're looking for. This is what we want to get when we're solving by elimination. We need to get same numbers with a variable. So you can see right here, 3y and 3y, one positive, one negative. Okay, everything's kind of in order. The x's are all in one row, the y's are in a row, the numbers are in a row. It's not as big a point that they have to come x, y on the same side, but they all have to be in the same spot, all matched up when I line up these equal signs here. Okay, so I can't just combine things together when the equal signs aren't lined up. Okay, so we're going to line up those equal signs, and everything here has to be kind of in order. Again, if it was something like 3y plus 2x equals 16, again, because these are both positive, I can just switch that order. Okay, so again, addition's commutative, so I can change the order on the same side without changing signs or anything, but that's kind of what we're looking for. So what's the steps to solve? Get one of these variables to cancel out. And all we're going to do then is add the two equations together. So 4x plus 2x gives me 6x. Negative 3 plus 3 gives me 0, right? 0. Negative 22 plus 16, bring our equal sign down, is 6, and it's negative 6. And now we're just solving the equation just like we would any other equation. Now we have a single variable equation, so we're just going to solve it algebraically. So divide here by 6, so x equals negative 1. Now we're halfway done. So now take this negative 1, and we're going to plug it back into one of the two equations. Okay, so it can be one of the original equations. At some point in the next equation or next example, we're going to modify one of the equations. Okay, it can be one of those equations. But you're going to take this x and plug it back in for x in one of those equations up above. So I'm just going to use the bottom equation. So 2 times negative 1 plus 3y equals 16. And again, I just used it because it's a little smaller numbers. So I'm going to work with smaller numbers here. So 2 times negative 1 is negative 2. And now again, we're solving algebraically. So adding 2 to both sides. So 3y equals 18. And dividing by 3. So then y equals 6. So again, you could take these two values, plug them back in each equation to double check your answer. But my answer then is written as a point, negative 1, positive 6 for my final answer then. So that's elimination. Now it can get a little bit harder. And again, we have 3 different options to solve these systems by. So elimination works good at certain times, substitution works good at certain times. So let's take a look at the next one. You can see here, we're going to solve by elimination. Now, in this case, I need to multiply one of the equations so that way when we add these together, they cancel out. Okay, so when I look here, I have, and again, they're set up already in the right order. Okay, x's, y's, and a number. I need to get these numbers to match up, one positive, one negative. So you can see here, 6 and 3. 3 goes into 6 evenly. So if I take this bottom equation and multiply everything by 2, and I have to multiply everything, so that's why I put parentheses around it. Everything gets multiplied by 2, then I'm going to have something that can cancel out. So 2 times 3x is 6x, plus 2 times 6 is 12y, 36 times 2, 72. And then again, I can just copy that top equation, so negative 6x minus 8y, negative 44. And now I add. So 6 and negative 6 is 0. 12 minus 8 gives me 4y. 72 minus 44 gives me 28. And then divide by 4. The y then equals 7. So again, it doesn't matter which one you solve for first, but I'm going to take that variable, this 7, and I'm going to plug it back into one of my equations. Again, now, I multiplied the bottom by 2, so if I want to take this 7 and plug it back into the original, again, my numbers are going to be a little smaller, so it may be a little easier that way. So, and that's what I'm going to do here. So I'm going to take the 3x plus 6 times 7, and that equals 36. Well, 6 and 7, that makes 42. Subtract that 42 then. So 3x, 42's cancel, and that gives me a negative 6. Divide by 3. So x then equals negative 2. There's my second part of my point. So my final equation, or final point, ordered pair is negative 2, positive 7. My final answer. So here I had to multiply by a number. I have a positive and a negative multiplied by a number on one of these equations to solve for the other. So take a look here at example B. I'm going to get you started and then you're going to finish this one. So here you see I have the exact same thing here with my x's, right? But they're both positive. So the only thing I really need to do is multiply by a negative 1. So, and it doesn't matter which equation you want to multiply by. So you can go through and really just change the signs if you'd like. So if I'm going to multiply this bottom one by negative 1, I'm going to go through and change my sign. So now I have a negative x, a negative y, and a negative 6. And now it's set up ready to combine. So finish this equation up and then check that answer with the video. So again, you're just combining those. So y equaled 4. The negative, or 2 minus 1 is 1y. So then I took that 4 and plugged it back in the bottom equation as the original, so they were both positive. So, and again, it doesn't matter which one you plug them into. So I have x plus 4 equals 6, and you can kind of see, well, if I add 2 to 4, I get 6. So x is 2, and 2, 4 is my final answer then. So the last examples here, these are the hardest ones. So in this, I have to multiply both equations by a number. So, and again, you can use any equation to multiply numbers to get these things to match up. It just depends on how much work you really want to put into it. So again, it doesn't matter which one I pick and choose. The 2's and 3's, neither one goes into each other. 5 and 8, neither one goes into each other. Some people may look at this and say, well, here's a positive and a negative. Okay, so you can use that. But again, if I multiply by 8 and 5, 40 is my numbers I'm looking for, right? So those are going to get pretty big. So sometimes depends on how big a numbers you want to work with. I personally like to work with smaller numbers, so I'm going to multiply this top one by 3. I'm going to multiply the bottom one by a negative 2, because one has to be positive and one negative. So here they had the same sign, so I got to include that negative with it. So in the top equation, 3 times 2 gives me 6x. 8 times 3 is 24y, and then a negative 24. Multiplying by negative 2 then, so I have negative 6x, a positive 10y, and a negative 44. And now I can combine my equations here. So again, zeros with my x's, 24 and 10 gives me that 34y. And then negative 24 and negative 44 gives me negative 68. And when I divide here by 34, y then gives me a negative 2. So again, part way done. Now taking that negative 2, and again, you may want to plug it back into an original. Numbers are going to be a little smaller. I plugged it back into the top equation. So again, then you can plug it in any one you want. So 2x plus 8 times negative 2 equals negative 8. So this is a negative 16. So we're going to add 16 to both sides. And then divide by 2. So 4, negative 2 is my solution. Again, biggest thing when you're writing this point, make sure x comes first, then y when you're writing these up. Not the one you found first and then the one you found second. X comes first, then y. So take a minute, solve letter B, check your work with the video. So this is kind of a special equation. You can kind of see these x's and y's both canceled. So I have a 0 over here. So does 0 equal 92? No, this is false statement, right? So just like we had before, again, you can have the exact same line. You can have one point that's intersecting, or you can have no points that intersect. So this is non-intersecting. This is going to be a parallel line. So this is going to be a no solution. Okay. So remember that. Again, these special cases, variables will cancel, and they're either going to be equal to the same two numbers, which will make it this equation true here. Okay. So if this is true, all real numbers. If it's false, no solution. Or I can get 1 point. Those are my three options for solving these. Okay, so you can kind of see the homework down the bottom right, 3-1 worksheet C.